everybody, welcome to the lecture number 2 of the chapter electricity. So guys, suppose you have watched the lecture number 1 of electricity and you have enjoyed that lecture too. In the lecture number 1, we did have a discussion about the charges. What are the methods of charging? And then also in the end, we did have a very important topic which is called the potential difference. So what you realized after studying that topic is that whenever we want to have the motion of charged particles, then we need a battery. Without battery, they are in motion, but that is a completely random motion. So if you want to have the motion of these charged particles in a well specific direction, then it's very important for us to connect through a battery, because battery will guide them to follow a certain path. So that was the importance of battery. So that's what we have learned in the previous lecture. Now in this today's class, what I'm going to do, I'm going to discuss with you a very new property related to the materials, which you have not done so far. And specifically, it is used in the electricity branch. So apart from that, we will be also learning a very important law in the electricity. I guess this is the first law you guys are going to learn in the grade 10, which is related to the electricity part. So that's the basic building block for the entire electricity, the law which I'm going to discuss with you. Once you understand this law, then only you'll be able to understand the lecture number 3. And the law is very simple, it's an experimental. So what is our today's topic for discussion? So here it is. So in today's class, we are going to discuss about the resistance, right? The factors on which the resistance of a body depends. And also we'll have the discussion about the Ohm's law. So just now I was talking with you about the law. So this is the law which I was talking to you about. So now what are the factors on which the resistance of a material depends? What are those factors? And what is resistance even before that? That also we'll need to understand. Second would be the Ohm's law. What is Ohm's law? What does it tell you and how does it helps you to calculate the current and voltage in the circuit? So we'll see everything one by one. So I hope you are ready now. All right. So let us begin with the first topic, the factors on which resistance depend. Now, first of all, what is resistance and what does it tell you? So resistance is like, in a normal way, if I say, it's like the obstacle in your path. So let us take one analogy here. I'll be taking few examples and then those examples would be exactly relatable here. Exactly in the sense like the theme would be relatable here. So suppose, let's say, I'm talking about two places, right? Okay, and I'll be talking about those two places. So let's say this is one place, Delhi, and there is another place. Okay, let me just draw it another side, just a second. Yeah, so that's that's Delhi. Okay, so this is some highway I have shown you, or highway, or you can say some local areas road I have shown you here. Okay, and at the same time, let us talk about some different place where the traffic condition is bit stable. Okay, so let us talk about Chandigarh, because Chandigarh is known for the best traffic management. So this is the Chandigarh road. Okay, so for now let us just assume that both the roads are of equal width. Okay, so let us assume that both the roads are of equal width. Either the road is in Chandigarh or the road is in Delhi. Both the roads are in are of equal width actually, 90 feet or whatever you could say. Now, guys, what will happen? So in Delhi, if you have got an experience, right? Because I did have experience, so I'm just sharing my experience only. Do not make it a general, but I'm just taking one analogy, so do not take it very seriously. Okay, and if you get offended, sorry for that. Okay, and if you're from Delhi, then I'm really sorry for that. See, what analogy I'm going to take here. Consider these two situations. Now, one person is driving his bike in Chandigarh. The another person is driving his bike in Delhi. Now, first of all, what matters is the traffic rules, like whether we are following it or not. So I'm telling you my experience. So if you come to Chandigarh, you will find that yes, most of the people are following the traffic rules there, right? And they know we have to stop at the red light. We have to stop. We have to what we have to do at the yellow light. They know everything. All right. And then we do have the proper traffic lights over here. But if I talk about Delhi, then maybe there will be no cameras. Maybe there will be no policemen standing there. Maybe. Okay. So there is a good possibility that you may just cross the road, right, without even looking whether it is a red light blinking, or is it a yellow light, or is it a green light, because it is more probable there and the population is also more. And at the same time, if I talk about Delhi place, then it is very much crowded, so it is a very poor traffic condition. And in the Chandigarh, it's not very much crowded, it's very stable, so the number of vehicles are not also not very much there on the road. So what I'm going to explain you from there, when you are riding your bike, what matters is the condition, your surrounding, right? So in Delhi, I guess it would be tough for you because you know the people there, and then you know the roads condition as well there. But in Chandigarh, that you will find easy. So you would say that yes, sir, Chandigarh is more suitable for me. But in case of Delhi, I'm getting the more obstacle, more difficulty I'm having. Similarly, exactly in the same way, when an electron or when a charged particle moves in a wire, it also has some problem, which depends on the material of the wire. So you can use different materials. Somebody can use copper material, somebody can use nichrome material, somebody can use some tungsten or some other different materials we people can use. So one thing which will depend upon the material, and that material would decide how much obstacle I am going to produce in your path. So that property of the material which decides this thing, that how much obstacle I'm going to put in your path, is called the resistivity. So that's the first term on which the resistance is decided. So resistance is very simple, the obstacle in the path. Now what is, on what first factor it depends? So first of all, it depends upon the material. So now this is the material property which we call as the resistivity. In some books, you will find that they write it as resistivity, or one more term you may see, it is called as the specific resistance. Specific resistance. Specific resistance. Okay. What is the unit of resistivity? It's ohm meter. This symbol is called ohm. OHM. So ohm meter is the symbol for resistivity. Always remember this. We should not forget. So ohm meter is a symbol for resistivity. Okay. Or is the unit for the resistivity, SI unit we can call it. And now, what is ohm? It's a unit of resistance basically. Just now I'll tell you. Okay. So right now I'm just discussing with you the properties, and then we'll discuss about the units as well. So resistivity is specific, is actually depending upon the material of the body, material of the wire basically. Now the second quantity. Before we go there, let us first of all talk about the values of resistivity, right? So first of all, if I talk about the values of resistivity, then you can see for silver, copper, aluminium, tungsten, nickel, then iron, chromium, mercury, manganese. The values is approximately, you can see, it's of the order of 10 to the power minus 8 ohm meter. But when we'll talk about for the other materials, then we can see that it is a little bit higher. Let's talk about the insulators. So for insulator, it is going in the order of 10 to the power 13, 14. It's very high. So for insulators, the resistivity is so high that they do not even allow the flow of current. So much obstacle would be there. And now you can decide your mind that this insulator belongs to which part of India. So this much poor condition you will find there for traffic. So hard rubber, ebonite, diamond, glass, all these things are the insulators, and they hardly allow the current of passes of current through them. But for the conductors, we can see these are the mainly conductors. See guys, you don't need to remember the values. I have not brought this picture just to make you to memorize these things. No, that is not required at all. But what you must emphasize here is like, okay, these are the metals and their resistivity value is very small. It's in 10 to the power minus. And these are insulator and their resistivity value is very high. That's what you should realize from here. And yeah, few observations we can make. Silver resistivity is lowest actually. You can see in the table. If it is lowest, then it will allow very good passes of current. But still, we do not use the silver wires because it is expensive. Yeah. So we use the wires of nickel. We use the copper wire, aluminum wires. We use them, right? I hope you have seen maximum wires like manganese. We have seen chromium. We have seen iron wires, tungsten, nickel, aluminum, copper. All these wires we have seen. All right. But usually we use nickel, tungsten, copper, aluminum, these manganese wires. We use them in our day-to-day life, the wires which we are seeing right now. Then alloys have the somewhere in between, but alloys also are very not alloys are also a good conductor. Some of the alloys, it's not like every alloy is a good conductor. So it's like that. Okay. Now the next part is about the factors on which the resistance depends. So first part is the resistivity. The resistance directly depends upon the resistivity. The symbol of resistivity is this. It is known as rho, R-H-O. That's the name of the symbol. It is called rho. So rho means the resistivity. It's a symbol. So first factor on which resistivity depends is rho. Equation number 1. I'm going to use it in the end. So remember this. Second factor. Let us go back. Okay, to one of the example. Let's talk about Chandigarh now. Okay, so now if you talk about Chandigarh, then this was the road of Chandigarh. Okay, and again I'll take two people. One person I'll take in the Chandigarh for this much length. Like he has to drive only this much path. So he starts from here and he goes to here. Now at the same time, the second person is in Chandigarh only. I'm talking about the same wire now. So you must be able to relate it now, right? I'm like roads are actually equivalent to the wire actually. All right. So now here we can see that we have the two vehicles again. The first vehicle, in the first case, the vehicle has to travel a smaller distance. But in the second case, vehicle has to cover a larger distance. So in which case you feel that the driver would suffer more obstacle? It's very simple to say in the case number 1. Because in the case number 1, the length is small. So if length is small, then he will suffer the same kind of traffic condition which is there on the length 2 for the smaller time. But for the second person, he is going to suffer for a longer duration. Okay. So basically, similarly, when we talk about the wires, then if the length of the wire is more, then resistance would be more. So resistance does depend upon the length of the wire, and it is directly proportional. And that's the factor number 2. So first factor is resistance depends upon the material. Second factor is resistance depends upon the length, and it is directly related. Now let us talk about the third factor. Okay, in the third factor, again, I'll be taking the two roads of Chandigarh. This is the road number 1. And it's not like, because I'm also in Chandigarh, so it's not like in Chandigarh every road is very good and wide. There are few places, right? If you go there, the roads are very narrow there. So that's the road number 2. Now it is clearly visible that in the road number 2, if you are driving your vehicle, now the traffic condition is same. You are in Chandigarh, so traffic condition is exactly same there. All right. So if I talk about that, then in the road number 2, you will find, okay, length right now I'm taking same. But still you will be, if you compare, then this motor guy bike in the road number 1 would be more comfortable as compared to the road number 2, because in the road number 2 the cross-sectional area, the area in which he can drive the car or he can drive the bike is very less. It's very narrow. So there is a more possibility that you have a fight there, right? Or there is a more possibility that you can hit somebody. But in the road number 1, it's a wide space, so you can easily drive your car. You will have enough space available. So actually, what is happening in the first case, you will have less obstacle, and in the second case, you will have more obstacle. So what I'm trying to say basically, when you have a wire of large cross sectional area I'm talking about, not the surface area. When you have large cross sectional area, right, then that wire would have the less obstacle. So the wire which will have the less cross sectional area would have the more obstacle, so more resistance. So resistance is basically inversely related to the area. Yeah. So more is the area, less is the resistance. Less is the area, more is the resistance. So that's how it works. So resistance is inversely related to the area. Now we have developed these three features, that the length, area, resistance, and everything we have understood now. Okay. So now if I combine all these three factors, resistance depends upon resistivity, factor number 1. Resistance depends upon the length also, factor number 2. And resistance depends upon the area, factor number 3. If I combine all these three things, then what I'll be getting? That's called the resistance formula. It was directly related to the rho, directly related to the L, and inversely related to the area. So that's how you get the resistance formula by the experiment. Actually, yes, we have done the experiment only just now, right? And yes, if we have some devices available, we can do that too. But this was a simple explanation I had given you by taking some analogies. I hope you have understood that part. So ultimately what I can say, that we have the final formula now, which is giving you that R is equal to rho L divide by area. So basically what is that? That is the resistance formula. We must remember it. It is the most important formula because electricity is one of the important chapter for the grade 10. So this is one of the important formula you are getting right now. The first formula you are getting, which is of very importance in the resistance, in the electricity. In the next class, we'll have more lot of formulas again, but this is the first formula which we should remember. Let's do one question based on this. So let us try with this question, a simple question. Question is, if the length of a conducting wire is doubled without changing the area is not changed, length is doubled. So originally length is L, and finally the length is made to L. Original area was A, final area is A. Okay. Then its resistance and resistivity will become. Achha, let us first of all talk about resistivity. Let's say in the beginning, the resistivity was rho. So can you tell me what will be the new resistivity? Think about it. It would be, before I answer, you must think about it. You can pause the video here. It would be exactly rho, because resistivity is not depending upon the length of the wire. It is depending upon the material. So if you take a nichrome wire, whether it is of 10 meter or it is of 20 meter, the resistivity, its property, material property. It's not related to the amount of the wire, like amount of molecules. So once you take the material, the resistivity value is fixed for it, right? Once you fix the city, resistivity value is fixed for it. If it is a Delhi, now we can guess the Delhi. Now, if it is Chandigarh, we can guess it's Chandigarh. Okay, so it's like that actually. So rho is same, it will remain same. So what about resistivity? It will remain same. Got my point? Okay, or it will not change. Now, what about resistance? So if initially the resistance I can write like this, rho L upon area. Now what will be the new resistance? R prime. So rho is same, length is made double, area is A. You can see this rho L upon A is nothing but old resistance. So R prime is equal to 2R. So resistance will become double and resistivity will not change. So that's the option A. So guys, that's simple question we have deal with, and that's how the people are asking the question in CBSE also. Instead of this, they might give you the radius as well. Like suppose we have the wire, and for that wire, let's say we made the radius double. So in that case, what will happen to the area? It will become 4 times, because pi r square. When you make the radius double, it becomes 4 pi r square. So area becomes ultimately, if it was A in the beginning, the cross-sectional area would become 4A. You must not forget that it is not always necessary that area has to be circular only, the cross-sectional area. It could have been a square wire also, square cross-section. It could have been a rectangle as well, though that is usually we don't see, but they can frame a question like that. So always be careful about it. So that was all about the resistance. It was a very simple topic, but very, very usual, important topic, because I'm going to use it in the upcoming classes now. So I hope you have understood what is resistance. So resistance is basically deciding the how much obstacle a electron is going to face when the current would flow through it. Now here comes the real topic of this entire chapter, which is the most important topic. And from this topic, yes, I can say that many questions are going to come in the grade 10, and this topic is going to be used in the grade 12 also many times, right? So we must understand this topic at a very small level as well, right? And the grade 10. And yes, in the next lecture series and parallel combination, we are going to have the discussion about this again. Okay, Ohm's law, because this is the important thing. So what we have understood in the previous lecture was the potential difference, which we denote by the symbol V. Okay, yeah, I forgot to one more thing here. That if you look at the resistance formula, R is equal to rho L over A. Just a second, I'll come back to Ohm's law. Now rho unit is ohm meter, length unit is meter, area unit is meter square. So meter square could cancel out. So resistance unit you will be ultimately getting as ohm. So that is the unit for resistance. Always remember, resistance unit is ohm. Resistivity unit is ohm meter. That's it. Okay. Now let's go back here. I just forgot to tell you the units here. So Ohm's law. Now when we talk about the Ohm's law, so what this Ohm's law tells you and what this Ohm's law is about. So basically, guys, this Ohm's law is about the resistance, the current flowing in the circuit, and the voltage which we are applying in the circuit. Actually, it's a completely experimental law. In the grade 10 may not be having the experiment, but in the grade 12, you guys will be doing the experiment if you go for science. So this experiment will be there for you people, and you would be getting one device called ammeter. You'll be getting one device called voltmeter. You'll be getting a battery in which you can change the voltage, and we will be also getting the resistors basically. Some wires will be getting, or we can use bulb as the resistors. And what you guys will be doing, let's say these are the batteries we have put here, 1.5 volt, 1.5 volt, 1.5 volt. So total 4.5 voltage of batteries are there, including the 3 cells. And here we have the resistor. If I keep varying the voltage, then what will happen? See, resistance is not going to get changed, because resistance is basically rho L over A. So resistance will not change. Resistance will remain same, because the material of the wire is same, its length is same, area is same. So when you increase the voltage, the resistance is not going to change. In some books you will find that resistance changes because of the temperature. So I'm not considering that much use increase in the temperature, because yeah, it's true that resistance does depend upon the temperature. If I tell you in brief, then actually this property of the material which I was talking about, resistivity, which I'm representing by the symbol rho, it directly depends upon the temperature. This temperature actually decreases the relaxation time, and because of this relaxation time of the molecules which are colliding inside it, and then because of this the resistance is going to change the temperature is going to change the resistivity value, and finally this resistivity value will be changing the resistance. So resistivity can be changed by temperature, can be changed by the material, but resistance can be changed by the resistivity. In short, it can be by the temperature and length and area as well. So right now I'm not considering that effect here, that I'm assuming that the resistance remains constant for these wires which I'm using. Okay. So what Ohm's has Ohm's law states that whatever voltage is applied to it, that is directly proportional to its current. So if you increase the voltage, the current would also increase. So more is the voltage means more is the energy. So more energy means those electrons which are there inside the material would have the more energy to run, would have the more kinetic energy now. All right. And they would move very faster and smoothly they would run now. The electron which was not able to move because of some obstacle, it was not able to come out, maybe that electron would also come out if you increase the voltage, and then the current would be used now. It will make almost every electron to move in the path, in the certain given path. So basically on increasing the voltage, the value of current increases. That's the Ohm's law simply. So when we do the experiment, what we do basically, we take voltage on the y-axis and current on the x-axis. Okay. And now I'm going to increase the voltage. So suppose if somebody has taken that at this is the voltage 5. So current value you get as 20. Okay, I'm writing as in volt and current is in ampere. So that is the first value we have got here. Let's say again we do the experiment, and second value which we get is 30 volt. All right. And this voltage is, let's say, 20 volt. Sorry, 30, 20 ampere and 30 ampere. Sorry for that. This is 5 volt. This is 20 volt. Okay, just a second. Just a second. Just a second. Yeah. Let me take some simple values here. 5 volt, 6 volt, and then this I'll be taking as 20 ampere, and this I'm taking as 24 ampere. Okay, these are experimental values which I'm writing. Okay, and then it is, let's say, 8 volt, and this will be, let's say, 32 ampere then. Okay, so these are the values we have got from the experiment. So these are the coordinates basically. 5 comma 20 is the first coordinate, 6 comma 24 is the second coordinate, 8 comma 32 is the third coordinate. So when we connect all these coordinates, what I'll be getting is a straight line graph. Okay, so the straight line behavior we are getting when we connect all these points, when we join all these points. So when the straight line behavior is coming, then what will happen is that we will make some observations that V is proportional to I here. But coincidentally, what happens is very amazing. And what is happening here, when you try to find out this proportionality, right? So we observe that in the here the proportionality which is coming out to be is the resistance of the wire. That is very amazing, that we are changing with I, sorry, we are changing, and that is making the current value also to change. And because of that, what is happening, that V proportional to I relation we are getting, the linear relation, V power 1 is proportional to I power 1. And what we find is the slope. So this proportionality constant is resistance itself. Now, if this relation is coming out to be a straight line relation, we have studied in the maths that y is equal to mx plus c. Now here the y-intercept is 0, so c is 0. So y is equal to mx, so m is called the slope. This m is called the slope basically. So here if you compare r is the slope, means in the voltage versus current graph, this is the slope, right? Tan theta, which we call. So tan theta is the slope. So what is the slope representing? It is giving you the resistance. It's a very, very important thing. It's a very much important thing. Many times CBSE has asked a question from it, that what is the slope of voltage current graph? So it is telling you the resistance. So that's what the meaning of this slope. So that's all. I hope you have understood what is Ohm's law. It's simply V is equal to IR. Okay, we must remember it. Let us see one question from it. So suppose, let me give you one simple question. First of all, like it's very, those kind of question I'm not taking. Like suppose they give you voltage equal to 20 volt and they give you resistance equal to 10 ohm. Simply what is the current? 20 by 10 V by R, so 2 ampere. Simple. Let's do another question. So voltage versus current graph, slope is giving you the resistance. Okay. So if graph was given to us, see carefully the graph. Some data I'm going to give you, some it's my imagination, so do not believe that these are the actually experiment have been done to collect these data. It's my imagination, just to frame the question. Okay, so 5 volt, 10 ampere, let's say it is 8 volt, 16 ampere, and third number I'm giving you 12 volt, and let's say 24 ampere. Find out the resistance. Find out the resistance of the wire for whatever it has been done, the experiment. So yes, we are getting a slope here, correct? So if you join them, all the points, you will be getting a straight line. Okay. So now try to find out the slope. That's what we have learned here. That resistance is basically is given by the slope. So you must pause here and try to solve the question yourself. So I hope you have paused the video and you have done the question yourself. Okay. If you haven't done so, then you must wait for me to solve. Before that, you should try to solve this question yourself. It would be better for you people. Okay, now let us go ahead. So actually, for this question, what should be done? All right, so let us have a look on that. So guys, if you see carefully here, then few things we can analyze, right? Okay, so only just look at these datas. Okay, just let us me just erase this part for your confusion. Okay, so when we look at this data, then we get a wrong intuition sometimes. Even though if I don't give you the data, I think that would be much better, because the purpose would be solved whatever I'm going to explain you here. See, if I just simply give you that this graph is having an angle 30 degree. So we know that slope is given by its current versus voltage graph. Slope would be 1030, but that is wrong. Resistance won't be 1030. It is wrong. The reason is V is equal to IR. That was voltage versus current graph, guys. You must see it carefully. So in the voltage versus current graph, resistance is the slope. True. But when you draw current versus voltage graph, then 1 by R is the slope, because I versus V graph is this. So here 1 by R will be the slope. So 1 by R is equal to, in this case, tan 30. So this is completely wrong. So you must understand the difference. If it is current versus voltage graph, then 1 by R is the slope. Tan 30 is nothing but 1 by root 3. So R we are getting as root 3 ohm. So that's it. It's very simple, but always look carefully which graph is this, whether voltage versus current or current versus voltage. Current versus voltage, and 1 by R is the slope. Voltage versus current, then R is the slope. Resistance itself is the slope. So that's all, guys. Now I hope you have understood the two important topics today. Resistance is rho L upon A, and also then another thing is the Ohm's law, V is equal to IR. Okay. Now in the next class, guys, we are going to discuss the series and parallel combination of circuits, which is another beautiful topic. And CBSE have been asking constantly one question from the topic, either the proving or the CBSE have been asking the numericals based on that. So that's all for today then. Thank you so much for listening. All right. And then if you have got any doubt, put it over the PDF. Thank you so much.